Hi, what are numbers? At first, that sounds like a simple question. We use numbers every day. 3 apples, 12 inches, 60 miles per hour. Numbers feel concrete because they help us count and measure real things. But the deeper mathematics goes, the stranger numbers become. Take a meter stick. It contains 100 centimeters. Halfway, 50 centimeters. And we naturally imagine that every possible distance between 0 and 100 exists somewhere on that stick. In mathematics, we describe those distances as points on a line. But that raises a surprising question. What exactly is a point? Euclid, the ancient founder of geometry, described a point as something with no width. But if every point has no width, how can a whole line have any length at all? How can infinitely many zero-width points create something continuous? The deeper we look, the more tension appears between two very different ideas. Things we count, discrete things, like apples, and things we measure, continuous things, like distances. And mathematics somehow tries to hold both together. When Newton developed calculus, he focused largely on physical motion, an apple falling from a tree, or planets moving through space, objects changing over time. These became powerful applications of calculus. But surprisingly, the deeper foundation of calculus was not really about apples or planets. It was about the abstract idea of real numbers. And for more than 200 years after Newton, mathematicians wrestled with the paradox of using discrete numbers to describe continuous motion and change. Now that may not sound like an important problem, but it became one of the great challenges in mathematics. And something beautiful happened through that struggle. By wrestling with these paradoxes, mathematicians not only placed calculus on firmer foundations, but also discovered entirely new ideas about infinity, continuity, logic, and the infinitely small. The struggle itself expanded human understanding. What makes this even more fascinating is that modern physics also reveals this tension. Things that appear continuous are often built from discrete pieces. Matter itself is made from particles. Digital images are made from pixels. Music streaming is made from tiny data packets. Our world constantly blends the discrete and the continuous together. And probably life does as well. We often want simple categories and clean answers, but reality keeps resisting those neat divisions. And the more time I spend reflecting on these paradoxes, the more I realize that they are not obstacles to understanding. They are invitations into deeper understanding. Because paradox slows us down. It forces us to think more carefully, to question our assumptions, and to remain curious. Perhaps wisdom begins when we stop demanding that reality become simple, and instead it allows its complexity to expand our understanding of the world we live in.